Hello, general physics once again. What we're going to be doing now is a common concept around any physics class at any level from high school all the way through college, which is vector addition. In the most basic sense, let's say we have two non-parallel vectors, just that we want to add together to get what's called a resultant. For one of our vectors, it has a magnitude of 8 meters per second with an angle of 60 degrees, which points it up and to the right. Whereas we have a second vector, vector b, that has a magnitude of 3 square root of 2 meters per second multiplied by, or at an angle of 45 degrees down and to the right. Well, breaking this stuff down, pretty easy. First things first, we want to break both vectors, vector A and B, into its y and x components. And that's straightforward. For vector A, its y component is just going to be its magnitude times sine of its angle. So, writing that down, what we're going to have is vector AY is going to equal our total magnitude of 8 meters per second. And to that, we are going to multiply it by sine of 60 degrees. Now then, let's see what happens when we plug that into our calculator. If we go into a calculator, normally you will have multiple options. Make sure it is in degrees. Do not have it in radians. We'll do that later in the semester. But let's say we have degrees. And if we're trying to solve for 8, let's take 8 multiplied by sine of 60 degrees. Or if you're using this, type in 60 and then go to trig and type sine. What this ends up giving us is the value, let's see, 0.866, that's sine of 60 degrees. Now let's put equal sign to get multiplied by 8. So that comes out to about 6.928. So what we have here is VAY, the y component of vector A, equaling 6.928 meters per second. Now, this is the y component. If we go back up, vector A, as we try to take the components from the tail of vector A to its head, its arrowhead, we see that the y component is going to be up or positive. So just to keep track of that, let's make sure that remains positive sign. Now the x component of vector A, that is pretty easy. What we're going to need there is its magnitude, which again was 8. And to that we're going to multiply it by cosine of 60 degrees. If you know what sine and cosine of these angles are as fractions, that's wonderful. That can help you save from having a huge decimal. But if not, that's okay. We'll just go from there. AX. So if we take our calculator out again, let's refresh everything, and we'll have 8 times the cosine of 60 degrees. Cosine of 60 degrees, that's just 1/2. So 1/2 times 8, that is going to give us 4. 4 meters per second, or whatever units our original vector was in. Last thing we're going to need to check for is the sign. We had a positive or a upward direction for our y component. we have a positive or rightward direction for our x component. So in other words, if your arrow is pointed to the right, that's positive on the x. If it's also pointed up, that's positive on the y. So let's make sure we keep track of that as positive. Now, we just found that those components for vector A. Let's do the exact same thing for vector B. Now, vector B, let's see. What we're going to have is the total magnitude of vector B, which we had as 3 square roots of 2, multiplied by sine of 45 degrees. Let's see, sine of 45 degrees. Now, from the top of my head, I know that 3, or I should say, I know that 45 degrees is the same thing as square root of 2 divided by 2. So if you don't know that, just plug in 3 square root of 2 sine of 45 into your calculator. But as a unrounded number, what we're going to get is square root of 2 multiplied by square root of 2, which equals 2. 2 divided by 2 equals 1. So effectively what we have is 3 multiplied by 2 times 1 divided by 2. Square root of 2 times square root of 2 is where we got this 2. The 1/2 is just from this 2 in the denominator. These cancel out, so we're just left with 3. Now, just one final check. We need to make sure that we have the correct sign for the y component of vector b. Vector b, what we see here is that this arrowhead is pointed down. That means that its y component needs to be assigned a negative number. So in that case, even though we initially got 3, what we want here is to set v by equal to negative 3 meters per second. The negative being the direction that vector b is pointed. Its y component, which is pointed downward. Just to do that on the calculator though, let's see, refreshing everything, we have 3 times, now let's look at, we want the square root of 2, and then we'll also multiply all that by sine of 45 degrees. So 45 sine, and now having all this put together, we get 3. So whether you want to substitute sine of 45 for its equivalent fraction, or just solve this in a calculator, you're still going to end up with 3. But don't forget to add in the sign of the direction. Next, of course, is the x component now of vector b, which that's going to be its total magnitude of 3 square root of 2 meters per second squared times cosine of 45 degrees. Now I know off the top of my head that cosine of 45 degrees is also equal to square root of 2 over 2. So this is going to end up equaling 3 again. But just to show that in a calculator, what we're going to have here is, refreshing everything, 3 multiplied by the square root of 2 multiplied by the cosine of 45 degrees. and that still equals 3. So what we're going to be left with is vector b's y component equaling 3, but now let's plug in the direction of it. If we go back to our main vector, vector b, not only was it pointed down or in the negative y direction, it was pointed to the right, which is the positive x direction. So to the right, positive x, down, negative y. So let's plug in that positive sign and also not forget our units. So now what we have here is the y components of both vectors and the x component of both vectors. Here's how we start plugging in that information. In order to find the y component of our resultant, we're going to need to add up the y components of each vector we added together. Well, we just had 2 vectors, so we'll just need the y component of vector A and vector B. Therefore, the y component of our end resultant is going to be vector A's y component, which we calculated that as positive 6.928. And we're going to add to that what we got for our y component for vector B, which was negative 3. Ay, ay, ay. Now, 6.928 plus a negative 3, that's just 6.928 minus 3, obviously. And what that gets us is, plugging that into our calculator, 6.928 plus a negative 3. Let's see. That's just going to be 3.928. So the y component of our resultant equals positive 3.928, roughly meters per second. Groovy. So now let's do the same thing for the x components. We only had 2 vectors, so we only have 2 x components from each vector. The x component of our resultant will therefore be the following. What we get is vector A, we found its x component to be positive 4. And we're going to add to that the value of vector B's x component that we found was positive 3. So that just becomes 4 plus 3, or positive 7 meters per second. All right. Now we have our resultant y component and our resultant x component. We know that it is going to have a y component that's positive, so our resultant arrow will be pointed up. It will have an x component that's positive, so it will also be pointed to the right. So our arrow is going to go along this direction. But let's find its actual magnitude and its actual angle. Now, that's easy. What we're going to do is take the following, which is we're going to take the square root of our x component squared, which we got our x component to equal positive 7. And whatever 7 squared is, we're going to add to that our y component squared, which was positive 3.928. And then we'll take the square root of all that. So first things first. If we take 7 squared, 7 times 7, that would be 49. And 3.928 squared or multiplied by itself is just that number. So 15.429, 15.429 15.429184. So if we just add that number plus 49, that gives us this. And if we just take the square root of that, what we're left with is approximately 8.026, or about, honestly, 8.03. So our resultant magnitude equals, let's see, approx 8.03 meters per second. Cool. Now, the magnitude, or I should say the direction, that's easy. What we're going to do for theta, or angle of our resultant, that's going to be the inverse tangent function of the y component divided by the x component. So if you have your handheld calculator, you're going to type everything like this. Let's see. You'll type that as clicking the inverse tangent button, and then you would fill in the y component value, 3.928, and divide it by the x component value of 7. And as long as your calculator is in degrees, what you should end up getting is, let's see, approximately 29.3. Let's see. Whoops, don't want that. So let's see, approximately 29.3 degrees. Not sure if this can be done on this calculator. Let's see. Do we have inverse tan? No, we don't. That's all right. Whatever the case. Anyways, you can type that onto your calculator using the button that says TAN to -1, and then just type 3.928 divided by 7, end parenthesis, and then get what that equals. Now then, here's what we know about our resultant. We know that it has a upward or positive y component, it has a rightward or positive x component, a magnitude of about 8, and an angle of 29.3. So let's draw that. We have a positive x component, a positive y component. So the tail, drawing from the tail of the first component we drew to the arrowhead of the final component we drew, that is our resultant vector. We're going to label it as r with a magnitude of 8.03 meters per second, or whatever units we had at the start. And we're also going to fill in that our angle between the x-axis and our resultant is 29.3 degrees. Now, for these types of problems, the only thing to additionally be careful of is when you're asked to draw the resultant, make sure you have it draw it facing the same way. If we instead had a negative y component, it would be pointed downwards below the x-axis. If we had a negative x component, it would be pointed to left somewhere. In any case, that should conclude this little additional guide into vector addition. As always, it's never necessary, but you can hit the like button, hit that subscribe button, and just for fun. In any case, wish you all the best on this guide, and peace.